I'm Shikha Kataria. I'm a PhD student at the Kelly lab in Cardiff. Our lab is really interested in understanding the link of different cellular processes in the cells and how they affect synaptic health and synaptic signaling. I'm particularly interested in the autophagy lysosomal pathway, so how our proteins are broken down in cells and how that is linked with neuronal activity. I am characterizing multiple cell lines at the moment that have the LRRK2 mutation for Parkinson's disease, and what I'm doing is I'm using multi-electrode array to look at electrophysiological changes in populations of cells over 100 days in vitro, so as the cells are maturing, seeing how their EPHIS changes. And what we're seeing in our wild-type cells is there's an increase in activity, and then it sort of stabilizes after 70 days in vitro. So they're hitting their electrophysiological maturity by about 70 days in vitro. What's really interesting is all the Parkinson's-associated mutations are hyperactive. So where the wild-type is stabilizing, they keep going up and up and up, and they're just on this hyperactive trajectory. What's also very interesting is when we look at the autophagy lysosomal pathway, so we're using this DQ BSA assay, which fluoresces when it's broken down in cells, and it gives you this punctate staining. When we're looking at the number of lysosomes and autolysosomes, these start to increase by 100 days in vitro. So what I think is happening is as the cells are becoming hyperactive, this is pushing changes in the autophagy lysosomal pathway, and these numbers of active lysosomes and autolysosomes are increasing as cells mature. We're also looking at synapse numbers, and we're seeing that the LRRK2 mutations cause alterations in synapse numbers. Either they start off really high, or they end up much higher by 100 days in vitro, but when you knock LRRK2 out altogether, we don't see that change. So where we're going from here is to really understand how these two pathways are linked. We're going to be using optogenetics, so we can laser stimulate cells to activate the autophagy lysosomal pathway or activate synaptic signaling, and then assess how the other is affected. And then we're going to be doing high throughput drug screens to see if we can find a common therapeutic target that can modulate both of these processes at once, and see if we can reverse any of the phenotypes that we're seeing.